Hello. I just started streaming. Can you see me? Okay, all cool. You are able to view these formulas which are written over here. Okay. Yeah. So now I should start with that. Okay, bro. Then I'm on it. Okay. Yeah. So hello, everybody. This is Suyash Goyal signing in. I hope you guys are doing very well. And today we are going to discuss about differentiation, which we are going to start with, and the basic topic which we are going to discuss in this next 1 hour is your chain rule of differentiation. So, I mean, I cannot discuss whole differentiation in just 1 hour. There are so many topics which we can talk about differentiation. If I name some specific topics, so yes, we have. Chain rule, we have quotient rule, we have product rule, we have logarithmic functions, we have implicit functions, we have parametric functions, then we have maxima minima, we have derivative as a rate measure, we have differential equations where we use differentiation. We have multiple applications of differentiation, and there are multiple branches of differentiation where we can actually use differentiation as a tool. But as we all know that there's a foundation to every step, there's a foundation to everything, and same goes for differentiation. So now when we talk about class 12th differentiation, it's a very lengthy topic. There are so many questions which you need to do, there are so many things which you need to do. But if we talk about the base, if we talk about the foundation of everything, then the foundation is chain rule. So everything starts with chain rule. May it be logarithmic function, may it be your implicit function, may it be maxima minima. Everywhere whenever you will be applying differentiation, the sole thing, the sole criteria which you will be needing, or the sole basic fundamental which you would need, is chain rule. Without chain rule you cannot think of doing anything. Just a moment. Okay, so now we will be starting with this differentiation chain rule. We just have 1 hour to discuss right now. It's I know that's not justice to you, but yeah, justice will be made to you and it will be delivered to you if you join us on an Academy learning app, because right now here we can just take 1 hour sessions out here. But when we talk about differentiation as a whole, so we are planning to launch a plus course which will be starting from 12th of April. And in that particular course, we will talk about everything, okay? Everything, as in everything related to differentiation for class 12. We will be talking about all the important questions which could be there, which can be asked to you, and the questions which have already appeared in previous year examinations. We'll be talking about all of them, and we'll be covering all the variants of differentiation, all the different parts of differentiation. But now here, because it is the basic foundation, the chain rule which I'm talking about, that's why we will just be focused about chain rule. Okay, we will just talk about chain rule. We will simply discuss chain rule out there. Got it? So let's start doing that without wasting any more moment. Now, to begin with, this is Suyash Goyal, and I've been associated with an academy since November 2017. These are lockdown days going on, and I'm really very sorry for what is happening out there. However, we are not mistaken in this, but yeah, that is some situation which has suddenly popped up, and this should not affect your studies. That is why we are making continuous efforts to ensure that you can learn from your home as well. We are we are trying to ensure that the same quality education can be delivered via internet channels as well, and that is why we are working, you know, all day all night just to ensure that we can deliver the best to you during these hard times. Okay, so now let's begin with this, the differentiation. I'll not waste much time talking about these formulas because this is something which you need to learn. Okay, so when I talk about differentiation, there are so many students who did not perform good in 11th because we have a mentality that 11th is a rest year. I do understand that. That's okay because we don't get that kind of guidance from the beginning that 11th is not a rest year. It is one of the most crucial year if you are planning to do further studies after your 12th. Let's say if you are planning to do engineering or any other science related course for your future, then 11th is very important in that particular scenario. But talking about differentiation, if you missed your 11th differentiation, that's okay. Okay, that's okay, don't worry about that. And believe me, whatever we will be discussing over here obviously has got something to do with the differentiation which you studied in class 11th. But if you did not study it, it will not make any difference. Okay, so we will be learning everything from the very beginning, from the very starting, just to ensure that if anyone has a upper level in terms of the differentiation skills and anyone has a lower level, so we can match them up and we can start together as a whole, right? So that is why we will be talking about differentiation from the very beginning. And here are some of the formulas which are written. So the first thing which I would like to request you all is that whenever you are going to start learning differentiation, whenever you are talking about differentiation, whenever you are planning to solve questions based on differentiation, these formulas which is written over here, which I will be speaking for you now, reading them out for you now, you just need to be very prompt in them. Okay, so these formulas should be on your tips. And when I'm saying should be on your tips, it means that whenever a question says what is the derivative of sine x, okay, do you know what is the derivative of sine x? Okay, so when I'm talking about the differentiation of sine x, so obviously you're gonna say it's cos x. But again, I'm saying, guys, second thing to note is speak right to learn right. Okay, so we cannot say that differentiation of sine x is cos x. We need to be correct in what we are speaking. So we need to say it in this way, that differentiation or derivative of sine x with respect to x is cos x. Okay, so there will be scenarios when you will be asked to differentiate sine x with respect to y. In that scenario, you cannot say that the derivative is going to be cos x. How can you, right? So if you want to learn right, the biggest thing which you need to do is you need to speak right. Okay, just speak right. So when you are learning, when you are in the initial phase of learning things, may it be differentiation or may it be any other topic, just try to speak right, because when you speak right, then you get used to it, and when you get used to it, it becomes a habit for you. Okay, you will automatically understand that sine x with respect to x is cos x, sine x with respect to any other variable is not cos x. Okay, got it? Now I'll be reading them out for you again. So derivative of sine x with respect to x is cos x. Is that clear? Okay, derivative of cos x with respect to x is minus sine x. Now I mean, I know you must be thinking that why we need to learn all these formulas, because these are the basic necessity of your class 12 differentiation. Okay, you need to learn them by heart. You need to learn them in such a way that whenever you are asked to do them, I mean, within fraction of seconds you should be able to answer that sin x का derivative cos x होता है, derivative of cos x is minus sin x, derivative of 10x is with respect to x is sec square x, derivative of cot x with respect to x is minus cos x square x, derivative of sec x with respect to x is sec x 10x, derivative of cosec x with respect to x is minus cosec x cot x. Okay, so these are some of the formulas. We have much more to deliver. Yeah, so this is the simplest one which you can see out there. Derivative of e की power x with respect to x is e की power x. Okay, then we have the next one, which is derivative of a की power x is a की power x log a to the base e. I repeat, derivative of a to the power x, derivative of a to the power x is a to the power x log a to the base e. Okay, now I'll tell you something about it. Then we have derivative of log x. Okay, derivative of log x to the base e is 1 upon x. Okay, so whenever you are differentiating log x to the base e with respect to x, then it will give you 1 upon x. Okay, next one is derivative of x to the power n with respect to x is n x to the power n minus 1. Now I would like to ask you one question, or I would like to discuss one particular thing over here, that the previous one, or the previous to previous one which we studied over here, is derivative of a to the power x. So derivative of a to the power x is a to the power x and then log a. So what is the basic difference between a to the power x and x to the power n? Okay, what is the basic difference between a to the power x and x to the power n? So the basic difference is that when I'm saying a to the power x, okay, so here the variable is x, right? The variable is x. We know what is constant, we know what is variable, right? So here in these formulas, the variable which we are talking about is x. Okay, and if you see a to the power x, so this is constant to the power variable. Okay, so whenever you have a question in which you need to differentiate constant to the power variable with respect to that variable, okay, so it will be constant to the power variable log constant base e. Got that? So when I'm saying a to the power x, it is what? When I'm saying a to the power x, it is constant to the power variable. And when I'm saying x to the power n, when I'm saying x to the power n, it is variable to the power constant. Now here you can see x is variable and then n. So examples for x to the power n is x to the power 2, x to the power 4, x to the power minus 5, x to the power 10, x to the power 12, x to the power 24. It could be anything. Okay, and if I talk about the examples for a to the power x, okay, so what will be the examples? 2 to the power x, 5 to the power x, 10 to the power x, 129 to the power x. Okay, so there are two things. First is variable to the power constant, and second is constant to the power variable. So be clear with that. Don't get confused between these two things. Okay, that's why I just clarified over here. Then the next one is if I need to differentiate 1 by x. Now this 1 by x is nothing but a version of your x to the power n. So 1 by x is what? 1 by x is nothing but x to the power minus 1. Okay, so when you will differentiate x to the power minus 1, so it will be minus 1 upon x square. Now it is just a part of this derivative of 1 by x with respect to x is just a part of derivative of x to the power n. But still I have written it down separately. Why? Because this is used very frequently. When you will go ahead and solve questions based on differentiation, this one will be used very frequently. That's why we need to remember this separately. Okay, the next one is root of x. Okay, now again this is again a part of x to the power n, because root x is nothing but what? We can write root of x as x to the power 1 by 2. Okay, root x is nothing but x to the power 1 by 2. So when I'm saying x to the power 1 by 2, the derivative will be 1 upon 2 root x. This is again used very frequently. That is why I have written it down separately. Now this was just a warm-up, and then we have constant. If you need to differentiate the constant, it will give you 0. If you need to differentiate variable with respect to the same variable, that means derivative of x with respect to x, it will be 1. Derivative of y with respect to y, it will be 1. Then we have some inverse functions. I'll not go into that right now because these are not needed as of now. And let's proceed to that, what we are supposed to do in this particular session. This is again the inverse. Now, what does a derivative represent geometrically? So geometrically, a derivative is nothing but it represents the slope of tangent to a curve at that particular point. So again, I am just trying to narrate the definition, but it is not needed right now because we are focused right now to discuss chain rule of differentiation. The geometrical definition, the physical definition, the mathematical meaning, everything we'll be talking about when we will have this particular course in detail. Right now, this is not the need of an hour. Moving forward, let's focus on what we are supposed to focus. This is your product rule. So when you need to differentiate u dot v, okay, now what are u and v? Okay, so you need to differentiate a function with respect to x. Now that particular function is the multiplication of two different functions. Now here u is also a function of x and v is also a function of x, and they are being multiplied. So whenever this is a scenario and whenever you need to differentiate u into v with respect to x, so it will be first function into derivative of second with respect to x plus second function into derivative of first with respect to x. Okay, so derivative of first function into second function with respect to x will be equal to first function into derivative of second function with respect to x plus second function into derivative of first function with respect to x. Okay, if I talk about division, so let's say I have two functions in such a way that they are being divided. So I have derivative of u upon v. So u is the first function, v is the second. Okay, so derivative of u upon v with respect to x will be what? Or I should say derivative of first function divided by second function with respect to x. So we can just expand it in this way. So denominator, so I have I have numerator and denominator. Okay, numerator is also a function of x, denominator is also a function of x. Now, so denominator into derivative of numerator with respect to x minus numerator into derivative of denominator with respect to x upon denominator square. I know these things must be complex to you right now. They must be appearing to be very complex to you right now. You must not be getting what I'm speaking again and again, but this is because we are not providing so much time to these things right now, because our focus is, our priority is something different. So I'm just narrating the things down for you so that you can just get a glimpse of all these things. Okay, now this is the product rule. Like you can see, I have two functions which are being multiplied. First is x cube and then 10x. So product rule will be applicable, and that's enough about this brief introduction. And now we will jump directly to that what we are supposed to discuss. Okay, so here we have chain rule of differentiation. Now what is chain rule of differentiation? There are two things. First is a normal function which we say x cube. So x cube is a function of x, or sine x is a function of x, or 10x is a function of x, or x to the power 5 is a function of x, x to the power 20 is a function of x, right? Now if I tell you that we talked about product rule, I told you one example of product rule, that is x cube into 10x. Okay, so I have x cube and I have 10x. So x cube is a function of x and 10x is a function of x. Got it? Right? Now if I just mix them up, how will I do that? Let's say I am not given 10x, or I'm not given sine x, or I'm not given x cube. I'm given 10 square x. What if I have 10 square x? Now this is not a normal function, it's a composite function. Now what is a composite function? When we have a function in a function in a function in a function and so on. What do I mean by that? So I told you 10x is a function of x, right? Now what I did is I put a square outside it. So now it became 10x ka whole square, right? So now it's a function of function. Getting it? No issues if you're not getting it. I'm going to tell it in multiple ways because this is something which is the crux, okay, of this chain rule. So 10x is a function of x. X square is a function of x. Okay, If I multiply them, x square is a function of x, 10x is a function of x, no issues with that. Now if I mix them up, which means first of all I am saying that yes, 10x is a function of x. Now I am putting a square on that 10x, so it becomes 10 square x or 10x ka whole square, right? So now it becomes a composite function, because first what I'm doing is I am forming a function of x which is 10x, and then I am forming a function of 10x which is 10x ka square. Okay, getting that or not? Right? So let me tell you in Hindi as well. So whenever we have function के अंदर function, okay, तो पहले तो y equal to 10x, this is one function, and then उसका भी मैंने square कर दिया. So this becomes a composite function. जब तक I have 10x separately, I had x square separately, तब तक ठीक था, या फिर मल्टीप्लिकेशन में तब तक ठीक था. बट नाउ आई हैव अ कंपोजिट फंक्शन, राइट? सो फर्स्ट ऑफ ऑल आई हैव अ फंक्शन ऑफ x that is 10x. After that I have a function of 10x that is 10x ka whole square. So that's how we do. Now how will we solve this particular thing? Okay, how do we do that? इसमें हम क्या करते हैं, whenever we have composite functions, which means whenever I have a function in a function, that time we make use of chain rule. Okay, so there will be multiple scenarios, or I would say all the scenarios, all the questions which you will be getting from now on in class 12 differentiation will be of composite functions. Okay, hardly you will find any question where you have where you do not have a composite functions. Okay, you will have composite functions and you'll have to differentiate them. How will you do that? Okay, this is the most important thing which we are going to discuss here, because this will be used in every question of differentiation which you will be solving in class 12. So please be very focused. If you have any question, please feel free to ask me at any point of time. Okay, I will love to answer, okay, all your questions. Now how do we solve that? I told you that derivative of sine x with respect to x is cos x. I told you derivative of cos x with respect to x is minus sin x. Okay, now I have y equal to 10 square x. So in this, first of all we find out the outermost function. Okay, first of all we find out the outermost function. हम ये देखेंगे कि सबसे बाहर कौन सा फंक्शन लगा है, एंड फ्रॉम दैट वो outermost function से होते हुए हम लोग innermost function तक आएंगे. What do I mean? I mean to say, so I have 10x का whole square basically. Okay, 10 square x का मतलब ये है कि 10x का whole square. Okay, so first of all I have 10x. This is the first thing which I have, that is 10x, and then I have 10x का whole square. So outermost function which I have is 10x का whole square. Getting that? फंक्शन ऑफ x तो मेरा क्या है 10x, और उस फंक्शन ऑफ x जो मेरा 10x है उसका मैंने स्क्वायर कर दिया है. Are you getting that what I'm saying? एक मेरा फंक्शन ऑफ x है जो कि है 10x, और उस 10x का जो कि मेरा फंक्शन ऑफ x है उसका मैंने स्क्वायर कर दिया, राइट? सो आउटर मोस्ट फंक्शन मेरा क्या है 10x वाला फंक्शन जो कि है 10x का होल स्क्वायर. सो नाउ वी विल टॉक स्टेप बाय स्टेप. आई नो कि अगर मैं x की पावर n को डिफरेंशिएट करता हूं विद रिस्पेक्ट टू x, इट गिव्स मी n x की पावर n minus 1. I know this. Whenever I differentiate what? Whenever I differentiate x to the power n. Whenever I differentiate x to the power n with respect to x, it gives me what? N into x to the power n minus 1. Which means if I differentiate x square, x to the power 2 with respect to x, it will give me what? N, that is 2, into x to the power n minus 1, that is 2 minus 1. So it will give me 2 into x की power 2 minus 1, that is 2 into x की power 1, that is 2x. So derivative of x square, derivative of x square with respect to x is 2x. Okay, derivative of x square with respect to x is 2x. Here I do not have x square, I have 10x का whole square. So what I'll do is, first of all I will differentiate 10x का whole square with respect to 10x. Do you get that or not? This is very important, guys, believe me, because I am not able to find Just a moment. Yeah, so because I'm not able to find what because I'm not able to find x function over there in the very beginning. The outermost function is not a function of x, it's the function of 10x. So I have 10x ka whole square. So what I'll do is, because I know that x square का डेरिवेटिव x के रेस्पेक्ट में 2x की पावर 1 होता है, right? So now because I have 10x का square, because I have 10x का whole square, so what I'll do is I'll differentiate it with respect to x. Okay, so जिस तरीके से x स्क्वायर का डेरिवेटिव x के रेस्पेक्ट में 2x होता है, जस्ट वॉच माई वर्ड्स, जिस तरीके से एक्स स्क्वायर का डेरिवेटिव एक्स के रिस्पेक्ट में 2x होता है, उसी तरीके से 10x के होल स्क्वायर का डेरिवेटिव 10x के रिस्पेक्ट में 2 10x होगा. आई जस्ट रिप्लेस्ड ऑल द x बाय 10x. दैट इज व्हाई आई टोल्ड यू, बी वेरी क्लियर कि जब आप फंक्शन को डिफरेंशिएट कर रहे हैं, देन बी वेरी क्लियर अबाउट द फैक्ट देन दैट यू आर डिफरेंशिएटिंग इट with respect to what. Be very clear about that you are differentiating it with respect to what. Okay, so derivative of what? Derivative of your function with respect to x, derivative of your function with respect to x is something, right? So I can say derivative of any function with respect to that function will also work in the same way, just like x square का derivative x के respect में 2x होता है, right? So 10x के whole square का derivative, 10x के whole square का derivative 10x के respect में होगा 2 10x, right? What is written over here? I hope it is clear to you. If not, please tell me. Any questions if you have? Guys, please tell me if you have any questions, anything you want to know, please tell me. Go ahead. I'm not able to see any questions from your side right now, but if you have, please tell me. I would love to answer them. So I'll assume that till now we are clear. Okay, let's proceed. Okay, so 10x के होल स्क्वायर का डेरिवेटिव 10x के रिस्पेक्ट में क्या है? 10x के होल स्क्वायर का डेरिवेटिव 10x के रिस्पेक्ट में 2 10x. Now because the derivative is 2 10x, now I'll multiply it with what? Let's see. So now what I did is I differentiated the outermost function, that is 10x का whole square. So I differentiated 10x का whole square with respect to 10x. Now the second function, right? The second function which I have inside this function is 10x itself. So first I differentiated 10x का whole square with respect to 10x. Now I will differentiate 10x with respect to x. So that is how step by step we will proceed. And all these terms will be just like communicating with each other with a sign of multiplication. So all these will be multiplied with each other. Okay, so 10x का whole square का derivative with respect to 10x is 2 10x. Now I will differentiate 10x with respect to x. Now this is very simple for me. I know 10x को जब हम x से differentiate करते हैं, x के respect में differentiate करते हैं, so it gives me sec square x. Okay, so it becomes 2 10x into sec square x. Now the next function is x itself, so x का derivative x के respect में is 1, so I have the 1. So the answer here becomes 2 10x into sec square x. Got that? I don't know, some of you might be thinking that I'm taking so much time to explain this very simple thing to you, or some of you might be thinking that, oh my god, how he's explaining, I'm not getting it. Okay, some of you might be thinking I am speaking very fast, but I'm just taking so much time on this particular question just to make sure that you understand this perfectly, because the whole story of differentiation, believe me guys, of class 12 depends on this chain rule. If there's some problem with the chain rule, there's going to be a lot of problems you'll face ahead when you move forward with your differentiation topic in class 12. Okay, so please be very clear about it. If you have any questions, please ask me, I'll answer them for you. but please be very sure about it that you got this, you understand this. Okay. Now, slowly we'll increase the pace of doing questions because we'll take more time for the initial 2, 3, 4, 5 questions, and once we are done with that, we will try to proceed fast. Why? Because when we are talking about chain rule, as I told you, these should be on your tips. These things should be on your tips. You should be able to solve these questions verbally, right? Just in a single step. So that is the kind of practice which you will try to do over here. Let's move forward. The next which I have is over here. Just a moment. Yeah, so the next question which I have is under root sine under root x. Now this is a complex one. I'll look into it. Let's see how many functions we have. So in the last question we had two functions. First is function of x, that is 10x, and then I had function of 10x, that is 10 square x. First of all, you need to understand how to identify it, okay, that how many functions are there, how many times you'll have to differentiate different functions, right? So if I talk about this particular question, I have under root sine of under root x. Okay, so always try to look after the x, always try to find x, that where x is written, and from there find out how many functions do you have. So x is in under root, so under root x is itself a function. This is the first function, right? Under root x is the first function. After under root x I have sine, so sine of under root x, this is the second function, right? Sine of under root x, this is the second function. Then sine is also under root, so under root of sine of under root x, this is the third function. So I have in total third function out there, right? And the outermost function is under root of sine root x. This is the outermost function, that is under root. Okay, just a moment. Yeah, got it, guys. So the outermost function which I have is under root of sine of root x. So under root of sine of root x is the outermost function. Again, what I'll do, I know that when I differentiate under root of x with respect to x, when I differentiate under root of x with respect to x, yeah, so when I differentiate under root of x with respect to x, what do I get? When I differentiate under root of x with respect to x, I get 1 upon 2 root x. I know that. Okay. I get what? I get 1 upon 2 root x. I know that. Okay. So when I differentiate under root x with respect to x, I get 1 upon 2 root x. So again, I will replace this x by sine of root x, because अब मेरे पास under root के अंदर x नहीं है, अब मेरे पास under root के अंदर जो function है वो है sine of root x. So differentiation of under root sine of root x with respect to sine of root x कैसे है? जिस तरीके से differentiation of x, or I would say differentiation of root x with respect to x is 1 upon 2 root x. Similarly, differentiation of root of sine of root x with respect to sine of root x will be what? It will be 1 upon 2 root sine of root x. तो कुछ भी नहीं हुआ, सिंपली हमने क्या किया, जहां जहां पे हम लोग रूट एक्स में एक्स लगाते थे वहां वहां पे हमने साइन ऑफ रूट एक्स लगा दिया. सो इन द बिगिनिंग वी स्टार्टेड विद that derivative of root of x with respect to x. That's how we started, right? That's how we started. That derivative of x with derivative of root x. Derivative of root x with respect to x is what? Derivative of root x with respect to x is 1 upon 2 root x. Similarly, derivative of root of sine root x with respect to sine root x will be 1 upon 2 root of sine root x. Is that clear or not? Clear guys? ओके तो अभी हमने इस पूरे एक्सप्रेशन को साइन ऑफ रूट एक्स के रिस्पेक्ट में डिफरेंशिएट करा है. सो नाउ एक फंक्शन के अंदर घुस गया मैं. नाउ अब दूसरे फंक्शन के अंदर घुसेंगे. सो नाउ आई विल डिफरेंशिएट साइन ऑफ रूट एक्स. फर्स्ट ऑफ ऑल आई डिफरेंशिएटेड रूट ऑफ साइन ऑफ रूट एक्स विद रिस्पेक्ट टू साइन ऑफ रूट एक्स. नाउ आई विल डिफरेंशिएट साइन ऑफ रूट एक्स विद रिस्पेक्ट टू व्हाट? सोचो. मुझे पता है साइन एक्स का डेरिवेटिव कॉस एक्स होता है, बट मेरे पास साइन ऑफ रूट एक्स है. तो यानी कि अब मैं साइन ऑफ रूट एक्स को एक्स की बजाय रूट एक्स के रिस्पेक्ट में डिफरेंशिएट करूंगा. ओके सो डेरिवेटिव ऑफ साइन ऑफ रूट एक्स विद रिस्पेक्ट टू रूट एक्स कितना होगा? डेरिवेटिव ऑफ व्हाट? डेरिवेटिव ऑफ साइन ऑफ रूट एक्स. डेरिवेटिव ऑफ व्हाट? डेरिवेटिव ऑफ साइन ऑफ रूट एक्स विद रिस्पेक्ट टू रूट एक्स विल बी, जिस तरीके से डेरिवेटिव ऑफ साइन एक्स विद रिस्पेक्ट टू एक्स होता है कॉस एक्स, उसी तरीके से डेरिवेटिव ऑफ साइन ऑफ रूट एक्स विद रिस्पेक्ट टू रूट एक्स होगा कॉस ऑफ रूट एक्स. अब इस साइन ऑफ रूट एक्स के अंदर कौन सा फंक्शन है? रूट एक्स. अब रूट एक्स को डिफरेंशिएट करेंगे एंड रूट एक्स इज नॉट अ कंपोजिट फंक्शन. रूट एक्स तो आपका सिंपल फंक्शन है एक्स का. तो रूट एक्स को डिफरेंशिएट करिए विद रिस्पेक्ट टू एक्स. सो डेरिवेटिव ऑफ रूट एक्स विद रिस्पेक्ट टू एक्स इज 1/2 रूट एक्स. राइट. रूट एक्स के अंदर आपका फंक्शन है एक्स. एक्स को डिफरेंशिएट करेंगे एक्स के रिस्पेक्ट में, दैट वुड गिव यू 1. क्लियर गाइस? Got that? Any questions so far? Because I'm not able to see any question from your side, guys. Let me just update this one once again. Okay, so I think things are clear to you till now, and we will proceed with the next question. Let's proceed with that, and this is the next question which we have. Yep, here we are. So now again you can see what I have. I have 10 cube x square. See, again I'm telling you the biggest point is to identify the outermost function, that which is the outermost function. Okay, सबसे पहले मैं किस डेरिवेटिव के साथ इसको कंपेयर करूंगा. ओके सबसे पहले मैं इसको 10x को कंपेयर करूं 10x के साथ कि 10x का x के रिस्पेक्ट में ये होता है, या फिर मैं ऐसे कंपेयर करूं x की पावर n के साथ कि x की पावर n का x के रिस्पेक्ट में ये होता है. सो आई नीड टू आइडेंटिफाई दैट फ्रॉम विच सिनेरियो शुड आई कंपेयर इट, एंड I can only do that comparison right if I am able to identify the functions right. I should be able to identify which one is the outermost one, which one is not the outermost one. So these things should be visible to me. I should be able to understand all these things very clearly, right? So now I have a function y. Y function is 10 cube x square. Okay, so it is 10 to the power 3 x square. Now you tell me, what do you think? What does it represent? So in this particular question, when I told you this one 10 square x, so that was basically 10 square x is what? 10x का whole square, right? That is why हमारा outermost function x की power n वाले फॉर्म का आया था. वहां पे हमने x को 10x से रिप्लेस करा, right? So 10 square x means what? 10 square x means 10x का whole square. Okay, now if I talk about this particular question, so I have y equal to 10 to the power 3 x square. So which means that this power 3 is the power of whole this expression, right? Which means 10 to the power 3 x square means 10 x square की whole power 3. Okay, 10 to the power 3 x square means 10 x square की whole power 3. Okay, 10 to the power x square means what? 10 to the power 3 x square means 10 x square की whole power 3. and now I am pretty sure that you must be able to identify the outermost function, that which one is the outermost function. Okay, to the power 3, that is going to be your outermost function. Okay, 10x square to the whole power 3. So this is your outermost function, right? Now when I will differentiate this with respect to x, how will I do that? 10x square to the whole power 3, 10x square to the whole power 3. So it is again like x to the power 3. If you see, the first function, the outermost function, is resembling like x to the power 3. So I have, instead of x, I have 10x square to the power 3. If I get inside that function, so instead of 10x, I have 10x square. So this is again a composite function. Okay, and inside this, that 10x square, I have x square. Now x square is not a composite function. Okay, so here I'll differentiate how many times? I will differentiate 3 times. Got that? Because first function is 10x square ka whole power 3, then 10x square, and then inside it I have x square. Okay, so that's how we will get inside a particular function from step by step. Okay, so let's start doing that. The first one is 10x square ki whole power 3. Okay, 10x square to the whole power 3. Okay, now if I have x to the power 3, so derivative of x to the power 3 with respect to x will be what? Derivative of x to the power 3 with respect to x is 3x square. Okay, derivative of x to the power 3 with respect to x is 3x square. Okay, so now derivative of what? Now derivative of 10x square to the power 3 will be 3 10x square to the power 2. राइट, सो कुछ ही नहीं किया, सिंपली x को रिप्लेस कर दिया 10x स्क्वायर से. तो जहां पर x की पावर 3 का 3x स्क्वायर आ रहा था, वहां पर 10x स्क्वायर की पावर 3 का 3 10x स्क्वायर की पावर 2 आ गया. ओके, फर्स्ट फंक्शन सॉल्व. आई डिफरेंशिएटेड 10x की पावर 2 विद 10x स्क्वायर की होल पावर 3 विद रिस्पेक्ट टू 10x स्क्वायर. Now the next step is to differentiate 10x square with respect to, now again I cannot differentiate 10x square with respect to x. I can differentiate 10x with respect to x and it will give me what? Sec square x. But I cannot differentiate 10x square with respect to x. तो क्या करें? Replace कर दो x को x square से. So let's differentiate 10x square with respect to x square. Right? सो जिस तरीके से 10x का sec स्क्वायर x होता है, उस तरीके से 10x स्क्वायर का sec स्क्वायर x स्क्वायर होगा. ओके, सो डेरिवेटिव ऑफ 10x स्क्वायर विद रिस्पेक्ट टू x स्क्वायर इज sec स्क्वायर x स्क्वायर into, now the next is what? The next function which I have is x square. So the derivative of x square with respect to x will be what? The derivative of x square with respect to x will be 2x. It's as simple as this. And that's how we got our answer. The answer is 3 into 10x square ka whole square into sec square x square into 2x. That's your final answer. You got that, guys? Okay, so that's how we do these things. That's how we compare these things. That's how I hope you understand how we are going through these questions. Okay, now moving forward, I have the fourth one for you. Now this one says y equals to 10 inverse of root x, right? So the question is y equals to what? The question is y equals to 10 inverse of root x. Okay, again, if you remember, yes, let's come back here. So we know sin inverse x का derivative x के respect में same goes with cos inverse x with respect to x. And if we talk about 10 inverse of x, so 10 inverse x का derivative with respect to x is 1 upon 1 plus x square, right? 10 inverse x का derivative with respect to x is 1 upon 1 plus x square. That is what we know. Now again, instead of x, what I have? Yeah, so instead of tan inverse x, I have tan inverse of root x. Had I been given tan inverse of x, so it would have been a simple question for me. Tan inverse x का derivative 1 upon 1 plus x square, question solved. But because I have tan inverse of root x, which means tan inverse के अंदर I have one more function which is root x. So there are in total two functions. It's a composite function, and the outermost function is tan inverse of x, where instead of x I am having root x. Okay, and then the next function is root x. So बिल्कुल बाहर से start करते हैं. So just like derivative of tan inverse x with respect to x is 1 upon 1 plus x square. So similarly I'll replace all these x by root x. So derivative of tan inverse of root x with respect to root x becomes 1 upon 1 plus root x का whole square. Got it? सारे x को रूट x से रिप्लेस करा तो tan इनवर्स ऑफ x का डेरिवेटिव जहां 1 अपॉन 1 प्लस एक्स स्क्वायर होता है, वहीं पर tan इनवर्स ऑफ रूट x का डेरिवेटिव 1 अपॉन 1 प्लस रूट x का होल स्क्वायर हो जाएगा. Got that guys? After that, now the next function is what? अभी ये किसके रिस्पेक्ट में करा है? डेरिवेटिव ऑफ tan inverse root x with respect to root x. Now the next function is root x. So now derivative of root x, derivative of root x with respect to x, it will be what? So derivative of root x with respect to x will be 1 upon 2 root x. Okay, so it will be 1 upon 2 root x. Got that? And that's how we solve this question. Simplify it, that now I have 1 upon 1 plus root x का whole square, that is 1 upon 1 plus x into 1 upon 2 root x, right? Okay, so now we are left with just 13 more minutes in our session. So we will try to pace up the things. We'll try to solve as many questions as we can, because till now I was very slow. Reason being that I want you to understand it completely. I want you to get used to what I'm saying. I want you to repeat what I'm saying so that you get this completely. Okay, now we'll try to pace it up. So next question is y equals to sine square e की power tan inverse x square. Okay, so now if you analyze this particular question, I have multiple functions over here. First of all, it is a composite function. Yes, once you identify it, identify the number of functions, which means how many times will you have to differentiate it. Okay, so the outermost function you need to identify. So again, just like that, tan square का x square, that was 10x square का whole square. So similarly I have sine square. किसका sine square? Sine square theta या sine square x. तो वो x की जगह मेरे पास क्या है? e to the power 10 inverse x square. So that's very complex or composite. Why? Because सबसे पहले तो मेरे पास sin x नहीं है, sin का square दे रखा है, first thing. सेकेंड थिंग इज साइन स्क्वायर देने के बावजूद जो अंदर मेरे पास x होना चाहिए, आई डोंट हैव दैट x. इंस्टेड ऑफ x आई हैव e to the power 10 inverse x square. So the first thing is I have e to the power, and instead of that I do not have e to the power x, I have e to the power 10 inverse of x square. And then I do not have e to the power 10 inverse x, I have 10 inverse of x square. Okay, so the outermost function here is what? As you can see, I have written it down in a much better way. In the next step, derivative of sine e to the power 10 inverse x square का whole square with respect to x. तो सबसे बाहर वाला फंक्शन वो स्क्वायर वाला फंक्शन होगा, क्योंकि साइन स्क्वायर लगा है, मतलब इस पूरे का स्क्वायर हो गया. Got it? So again we will deal it like what? We will deal it like x to the power n. Okay, x to the power n, and just like x to the power n का डेरिवेटिव x के रिस्पेक्ट में n x की पावर n माइनस वन होता है, just like x to the power 2 का डेरिवेटिव x के रिस्पेक्ट में 2x होता है. Similarly sin e to the power 10 inverse x square का डेरिवेटिव sin e to the power 10 inverse x square के whole square का डेरिवेटिव sin e to the power 10 inverse x square के रिस्पेक्ट में it will be 2 sin e to the power 10 inverse x square. Make sense or not? Okay, So I simply replaced x by sine e to the power 10 inverse x square. So it becomes, the first step becomes 2 sine e to the power 10 inverse x square. Now second would be my sine. So now I'll remove that square and I'll come inside that function. So the next function which I have is sine e to the power 10 inverse x square. Now I know the derivative of sine x with respect to x is cos x. I know the derivative of sine x with respect to x is cos x. Okay, so derivative of e to the power 10 inverse x square with respect to e to the power 10 inverse x square will be cos e to the power 10 inverse x square. So again I replaced x by what? I replaced x by e to the power 10 inverse x square. Okay, so derivative of sine x is cos x. Similarly, derivative of sine e to the power 10 inverse x square is cos e to the power 10 inverse x square. Okay, now next step. Now let's come inside this sine. So inside the sine I have e to the power 10 inverse x square. And just like when we have e to the power x, so derivative of e to the power x with respect to x is e to the power x. Similarly, derivative of e to the power 10 inverse x square with respect to 10 inverse x square will be e to the power 10 inverse x square. Okay, now let's get inside that function. So inside it I have 10 inverse x square. Now derivative of 10 inverse x with respect to x is 1 upon 1 plus x square. So derivative of 10 inverse of x square with respect to x square will be 1 upon 1 plus x square ka whole square. Got that, guys, or not? Come on, tell me. Derivative of e to the power 10 inverse x square with respect to 10 inverse x square is e to the power 10 inverse x square. Coming inside, derivative of 10 inverse x square with respect to x square is 1 upon 1 plus x square to the power 2. Okay, now let's get inside it. So inside 10 inverse x square I have x square. So derivative of x square with respect to x is 2x. That's it, I'm done. So the most important thing which I would like to convey over here is that never get frustrated or afraid of any question. Never get afraid of any question, because if you have a question, does not matter what is the length of that question, how much steps there will be in that particular question. If you know the concept right, you will do it right. Yes, I understand it might take more time, but that's okay. You will solve it, and once you solve it right, it is going to boost your confidence like anything. Okay, so that's why I'm focusing more on the concept, that just try to get the concept right. Okay, just try to think and get the things right, get the concept right. Just try to understand the concept, how we're going to solve it, what are the steps which I need to follow, and step by step, step by step, solve that question. You'll get the right answer. Getting that, guys? So do not get afraid of any question which is lengthy. I mean, if you have the concept right, if you know the things right, you will solve it for sure. Be confident about it. Okay, all right. Moving forward, we'll take one more question. That's it. Yeah, so this is the question which we have. There is, okay, so I would say it is a bit similar to this one. So here we have e to the power 10 inverse x square. Now here we have y equals to e to the power 10 inverse 2 to the power x. Okay, so again I have e to the power x form, but x is replaced by 10 inverse to the power x, and then again inside that 10 inverse I do not have x, I have 10 inverse 2 to the power x. So there are three functions which I can see. First one is e to the power 10 inverse of 2x, second is 10 inverse of 2x, third is 2 ki power x, right? Let's solve that. So derivative of e to the power x with respect to x is e to the power x. So derivative of e to the power 10 inverse of 2 ki power x with respect to 10 inverse of 2 ki power x will be e to the power 10 inverse of 2 ki power x into derivative of 10 inverse x with respect to x is 1 upon 1 plus x square. So derivative of tan inverse of 2 ki power x with respect to 2 ki power x, it will be 1 upon 1 plus 2 ki power x ka whole square. Got that? It's fun, guys. If you just do it step by step, it's fun. Coming inside it, so the next function which I have is 2 ki power x. Now understand, that's not variable to the power constant, that's constant to the power variable. So it's the form of a to the power x. And derivative of 2 to the power x will be 2 ki power x into log 2 to the base e. And then x ka derivative x ke respect mein it will be 1. Clear, guys? Got that? So that's how we actually solve these questions. Let's take one more because we have time. The next one is y equal to 1 upon log x. Now I know about log x. If I have been given log x, I know derivative of log x with respect to x is 1 upon x. But instead of log x, I have 1 upon log x. So again, it's a composite function. So first of all, tell me what is the derivative of 1 upon x? I told you that was a special case which we learned, as I told you that there will be multiple questions based on this. So 1 upon x ka derivative x ke respect mein minus 1 upon x square. Similarly, 1 upon log x ka derivative log x ke respect mein it will be minus 1 upon log x ka whole square. Then I'll get into log x. Derivative of log x with respect to x is 1 upon x into derivative of x with respect to x is 1. And that is my answer, which is written over here, minus 1 upon log x to the square 2 to the power 2 into 1 upon x into 1. That's it, we are done. Got that, guys? So that is how we need to use chain rule for all the questions which are based on differentiation. I hope this particular session was helpful for you. Sir, how 1 plus x square comes? So indeed, I lost you, Shoaib. Which question you are talking about? 1 plus x square come. Okay, are you talking about this question? 1 plus x square. So that is, yeah, I tell you why. That is because when I'm talking about a derivative of tan inverse x, derivative of tan inverse x with respect to x is what? Derivative of tan inverse x with respect to x is 1 upon 1 plus x square. Okay, तो अब हमने क्या करा? Yeah, I'm telling that in Hindi, no issues about that. Now we have tan inverse of x square. So instead of differentiating it with respect to x, अब हम इसको x square के respect में differentiate करेंगे. तो जिस तरीके से tan इनवर्स x का डेरिवेटिव x के रिस्पेक्ट में 1 अपॉन 1 प्लस एक्स स्क्वायर होता है, उसी तरीके से tan इनवर्स ऑफ x स्क्वायर का डेरिवेटिव x स्क्वायर के रिस्पेक्ट में 1 अपॉन 1 प्लस एक्स स्क्वायर का होल स्क्वायर होगा. गॉट दैट शोएब? ओके, सो दैट इज व्हाई इट इज 1 प्लस एक्स स्क्वायर का होल स्क्वायर. So that's it, guys, from my side for this particular session. I hope you liked the session. You had a good time learning this chain rule. I hope you got the crux behind this chain rule, and I hope that you're going to use this funda, use this way of solving questions based on chain rule for the coming questions. And also, we are going to start with a plus course based on differentiation. As I told in the beginning of this course, that we will be talking about everything on that particular in that particular course, which will be starting from 12th of April of this particular month, 12th of this month. And you can subscribe to that course if you are interested in learning everything about differentiation, and we will talk about all the important questions which have been asked earlier in board examinations. Now this is my code, this is my referral code, which you can see over here. Use referral code 10 on plus. You can download Unacademy learning app, go to